Hey y'all, it's Andy Couch here, and this Title Tuesday video, we're gonna be finishing up our UFC sports betting model from scratch project. But before I start this video, I wanted to show you a little thing I found from Twitter, and basically it's adding a little nicer README file onto your GitHub profile. So I saw it from I guess Monica. She had a nice tweet about it, and then she also has a website kind of displaying how to do it. So I wanted to show you my README that kind of elevates my profile, and it's just a simple markdown document with the repo name under your username. So definitely check it out. It's pretty cool. This README or this little profile section literally took me 2 minutes to make. So I think it makes it a little bit better, and I think it's something that a lot of people on GitHub aren't aware about. So just something to show. Also, before I start this video, next week will be my 1 year anniversary for with the Tidy Tuesday project. So I figured I'd be finishing up season 1 of the Tidy Tuesday series with a Q&A. So I'll also have a Q&A submission form linked below in the description, so you can ask me a question for that video. Okay. So let's actually go over from what we started from for our previous video about the feature engineering and modeling. So I actually finished up the modeling. I did the evaluation, and we actually found that the XG Boost models performed the best compared to the other models. I tried out a few random forest models, a few PCA regression models, etc., and the XG Boost models seemed to perform the best. That's pretty good. One of the things I actually had to do was build a pipeline. And one of the problems I actually faced was I was kind of being lazy with the actual modeling. So, for example, all of our actual submission metrics or our actual head-to-head metrics that we created was through our feature engineering pipeline, and we essentially just hard-coded these features. What I actually wanted to do is basically have those types of feature engineerings basically embedded into our recipes. So that's what I basically did. I used our models that we made in my previous video and basically changed out the recipe so that we have our actual head-to-head metrics. So we have our strike differentials, our strike favorabilities, whether or not the opponent is favored using the elo scores, etc. So that's one thing I added. It looks like a lot of code, but I essentially just copy and pasted on the code from our feature engineering. So nothing too crazy, and nothing really changed. They're essentially the same models, but it adds a little bit more to our pipelines. So yeah, nothing too crazy. I just did that. I also saved all the models to our little modeling folder right here. So we have about, 6 models? Our 5 models that model out the components, and then a final outcome model. Okay, so let's actually go to the final part of our project, which is actually kind of like showing it to other people and letting people actually use our models. So I'm gonna open up our app, and here's the app. I'm gonna run the app first before we actually go over it. Okay, there we go. And then we have our Shiny dashboard app. It's a pretty simple dashboard. It's only 3 tabs, and 2 of the tabs we've already really made. So not a lot of code. This app actually took me about, I think, 3 hours on Sunday. And a lot of it was me doing other stuff, such as writing some other scripts and stuff like that. So we have our little dashboard right here. And we've added Plotly where I thought it would be most beneficial. So we have our number of outcomes for our fights by type. We have our elo distributions using Plotly, and we have the fighter with the highest elo score for that given weight class in the history, where you can highlight it and it'll show you the name, weight class, elo score, etc. So a Joanna, again for strawweight, flyweight, and then for featherweight, Amanda Nunes, bantamweight, Amanda Nunes, welterweight, George St. Pierre, etc. So that's pretty cool. You can do some highlighting too, and stuff like that. I also have used some GG ridges to show basically the percentile distribution of all of the metrics. So we can see our knockdown distributions are pretty similar across the different weight classes. And then with significant strikes landed, we can see that women seem to have a little bit more higher distribution or more skewed distribution where they have a little bit more higher output for significant strikes landed. Right, single strikes landed. And again, with submission attempts and takedowns landed, they're pretty much the same across the classes. And then we have a little bit of like a top five outcomes, or top five components. So which fighters had the most knockdowns, most amount of significant strikes landed, total strikes landed, total sub attempts, etc. And we also have total wins. So yeah, pretty good like kind of summaries of all the weight classes. I haven't added any filtering to it. It's because I wanted to focus mostly on the modeling. Okay. So now we have our actual probability or model probabilities where the people using this dashboard can actually use the models that we created to predict outcomes to hypothetical fights. So one of the things I wanted to do was, okay, let's show maybe Conor McGregor. Where's Conor McGregor at? Well, actually, we can probably type this in. Conor McGregor versus like Dustin. Oops, come on. Dustin Poirier. And one of the things I do want to add is like a little button so it doesn't do the predictions all the time, where we can just like choose our fighters and then press the button. But I didn't get to it. So we can see that Conor McGregor has a 20% chance of winning, and we know the outcome of the fight where Dustin Poirier actually ended up winning. Since we actually have a recent fight, recent title fight that we observed, I guess, last Saturday, which is Gilbert Burns versus Kamaru Usman. Kamaru Usman ended up doing a TKO to Gilbert Burns on the third round. One of the things that Kamaru was talking about was he wanted to challenge. He wanted to challenge, who was it? Jorge Masvidal. So I think that'd be kind of interesting to basically do a hypothetical matchup. So let's just do Kamaru. So with Kamaru, Kamaru Usman versus Jorge Masvidal. Right, even though we know that Kamaru Usman has already beaten Jorge Masvidal, let's actually see the predicted fights. And we can see that Kamaru Usman has a 77% chance that our model is predicting for Jorge to win the fight. Pretty cool. I'm going to do one more thing because I think it'd be interesting to see Stephen Thompson fight Kamaru Usman. Let's see if it changes. So it gives the Kamaru Usman having a 67% chance of winning against Stephen Thompson. As you can see, the margins are a little bit more tighter. So for me, I think that'd be a more interesting fight to see. Because I actually really like Stephen Thompson a lot as a fighter. Okay. I also added one more feature, which is the upcoming card predictions. I essentially just scraped the 5 future cards and then basically apply the model towards all the fights that were available. And I thought that'd be pretty useful, especially if someone's going to use this dashboard. You know, they want to not just they don't want to have to like enter in each fight in our little fight predictions tab. Instead, we should just have the actual our upcoming cards and the probabilities and stuff like that. So I used the table and we basically outputted the probabilities. I actually scraped these cards on Friday because I wanted to get that done. So I scraped the cards and then started building pipelines on Sunday. So we can see the predictions for the Kamaru Usman and Gilbert Burns fight. We can see the Macy Barber versus Alexi Grasso. You might also see that we have these little intervals. We have the lower, the predicted, and then the upper probabilities of the fights. And one of the things that I found that was kind of interesting, which makes sense, was that if I predicted Kamaru Usman versus Gilbert Burns, and then also did Gilbert Burns versus Kamaru Usman, so we swapped out the fighters and opponents, the probabilities didn't actually line up 1-to-1. They weren't exact complements of each other, but they followed the actual trajectory. You know, is it above 50 or below 50% pretty well. So what I actually did was basically just averaged them out, or took the median between the probabilities, and then used the upper and lower limits between the two fighters' probabilities as the lower and upper limits. So we kind of have some intervals, which I think actually adds a little more information about the model's predictions. We also have our average round estimations of the components that these models are predicting. So we can kind of see why this model is thinking that Kamaru Usman will essentially beat Gilbert Burns um, with a high amount of certainty because because the model believes that Kamaru Usman will have way higher significant strikes, way higher strikes landed, and a little bit higher takedowns. Even though it's essentially estimating pretty low submission attempts and takedowns, um, it's really thinking that Kamaru Usman will just have will basically outstrike Gilbert Burns, which actually ended up happening. So I think that's pretty interesting. Again, against Macy Barber versus Alexa Grasso, we can see that these intervals are pretty tight compared to relatively to Kamaru Usman and Gilbert Burns. We're still giving Alexa Grasso the edge, about a 58% to 42. But we can see the intervals also kind of clash with each other. But we can actually see why our model is saying that Alexa Grasso should beat Macy Barber is because they think Alexa Grasso will have some edge in the significant strikes landed and also strikes landed. It also thinks that the submission attempts and takedowns are pretty similar. Maybe that Alexa Grasso has a little bit more takedowns than Macy Barber. So that's pretty interesting. One other thing that was a little odd is actually really under predicted Kelvin Gastelum with Ian Heinisch. So that's pretty interesting too. And then it also mispredicted Ricky Simon versus Brian Keller. But it gave the probabilities of Brian Keller beating Ricky Simon in a pretty tight interval. So I'm pretty fine with that. Lastly, we have the actual probabilities in a little plotly with the intervals. So we have, Thiago Santos versus Alexander Rakic. And we see like this is Thiago Santos. They think Alexander Rakic will win, but we can see how the probability intervals kind of overlap, right? Whereas opposed to Kevin Gastelum and Ian Heinisch, our model really messed up a lot and basically was really under predicting Kevin Gastelum. Maybe I could see why it's predicting that, but that's what it's saying. So maybe because Kevin Gastelum has been on a loss streak, and that's why it's under predicting it. Okay, so let's actually go over the higher level thing of our app. Most of the actual logic is actually in the modules because I actually ended up modularizing a lot of the components. But we can kind of see, we just load in our packages, our data. We have 3 menus. Again, nothing too crazy. We have our modules that I created. So an outcome plot, elo plot, component plot, best plot. Nothing too crazy again. And then we can actually go into server functions. One of the things I actually really ran into a problem with, which actually wasted a lot of my time creating this app, was I kept on running into errors where I wanted to basically make modules for these selectors, but I kept on running into some issues. I don't know if it's because I was trying to use these modules within other modules and reactive variables, or I probably just needed to add a little function or do something different. But I kept on running into that error. So I ended up just hand coding these inputs and stuff like that. Not sure why it wouldn't work for me, but it's something that I ended up doing, and I think that's fine for what I did. Then we have this reactive function, which is basically this reactive variable that is basically the meat and potatoes of our actual predictive tab. So with given a selected fighter and a selected opponent, it basically combines all that model data together. And then we have our fighter's data and then our opponent's perspective. So for the fighter opponent, we have our fighter component. And then for the opponent component, it essentially switches them together. So we have the opponent's perspective. That way we can get 2 different sets of probabilities. And then finally, we kind of combine them together to get the outcome. Okay, which will do the actual prediction using our little helper function that I imported. And again, we have these little boxes that basically selects the average probability of winning, the average probability of losing, because it's all from the perspective of the fighter. Right? Now we have our servers. Again, nothing crazy. We just have our little ID and then our input, which is our data frame. So if you actually look at this, app, it's actually a very simple app. And it's pretty easy to read. I think if you are a beginner in RShiny, you kind of get an idea of like what was going on pretty easily. And I think this is a very clean app that I wrote. Not trying to pat my own back, but let's actually go over the modules, which is probably the bigger things. But again, it's not too crazy. I basically loaded in all my models from here. One of the problems I actually had with sharing this I guess, repo or project was that the models got really large because I usually would put it in one entire RDS object for like final models, which is like all 6 models in one little RDS. But it was too large for me to upload to GitHub, so I just uploaded them independently or individually. One of the things that I probably would change is actually use Butcher to remove some of the excess space that was in there, maybe to make it a little bit thinner so I could upload it together. But yeah, so we have our actual outcome modules right here. Just using ggplot and ggplotly. I also would wrap in my UI with a box, so that way it's a little bit more cleaner. But most of it was actually the let's see here, our fighter components. So in the fighter components, we actually predicted it would return a tibble with the predicted component outcomes, and then again we would use that same data frame and kind of replace it right there. So we have our fighter and our opponent components using our opponent and our fighter. And then finally, it would basically just combine those fighter and opponent predictions, predict using our outcome model, and then summarize it, getting the average probabilities with the upper and lower bound. Okay, so nothing too crazy. Okay, so that's basically it for this project. I know that this app seems pretty, for all the work we did, actually displaying it was pretty simple to do. And that's kind of what I wanted to do, really. I wanted to make this into an app. One of the things I would like to add, I'm just kind of doing a little self-reflection on this project, was maybe adding more report style stuff. So I think improving the UI of it. So with fight predictions, adding, maybe some plots of like, oh, like here is the fighter's profile picture. Maybe also like right on this fighter predictions, like give you the expected components and show the other fighters' expected components right there. But the main things I would really change with this project is not necessarily the dashboard, because I think all dashboards can be improved, right? Maybe remove that little underscore to a space, stuff like that. But think about the actual model itself. There are a lot of things I would change with it. So one of the things I would change with the model that I really didn't have time with is basically calibrating the model probabilities. So one of the things I wanted to do, because this essentially was supposed to be about a UFC sports gambling model, was assess the model probabilities towards like a money line, and then convert that money line to a probability and define a custom metric for it, right? So one of the things that we want to do is make sure our model is essentially at the more severe end of the probability. So essentially like a mean log loss using that sports gambling probability. So if a sports gambling money line is saying that Alan Belcher has a 70% chance of winning, and then Alan Belcher actually ends up winning, we want our model to basically be more certain that Alan Belcher will win. So that way we actually understand that our money line that our model is giving can have a little bit more margin, can give us a little bit more return in our picks, because we're willing to choose the end of the bet with more certainty, stuff like that. So having something to calibrate the probabilities while considering the sports gambling probabilities of a money line or some American odds is something that I would like to add. The big thing is I need to get some money lines and odds and spreads from a UFC site, and also be able to join it with my data set, which I haven't got to yet. One other thing that I would like to improve this model is see how removal of certain samples would improve the model. So one of the things I added, which I think is artificially increasing the error of my models, is using all of the data. One of the things I think is important to understand is it's better to have high quality data than a lot of data, usually. So one of the things that it's always predicting is it's having inputs where we don't have any data about our fighter, right? Because it's their first fight. We don't have the past 3 fights. We don't know how their total fights. It's all 0, except their ego score is 1500, which is like the default score. So using that and just filtering out, like, hey, if the fighter hasn't fought once, maybe we should remove it, and see how that improves our actual, validation accuracy, or technically our validation root means squared error and stuff like that. So definitely considering that for our models would definitely improve it. that I think would at least improve it. Additionally, doing some more uh post hocs on our model. So I think one thing that would be interesting to model is adding about like why is our model predicting uh that Alan Belcher is going to have 3 knockdowns for that fight, right? So adding some type of line model into our dashboard would be kind of interesting to see, just on why it's predicting it, and maybe even adding some things where we can say like, oh well, our model is saying this guy or this fighter is going to have this many strikes because his past experience or his past 3 fights where it was just an anomaly. So maybe we want to actually tweak that individual component and just like decrease a little bit manually and then put it into our model or our outcome model. So having that kind of like fine tune feature where we can have a person who actually understands the context of the fight, make some adjustments to our input data for our outcome model, could actually improve it and add a lot of functionality and add a lot of interactiveness to this dashboard. But with that being said, I really enjoyed this project a lot. I thought it was pretty fun, and hopefully you guys liked me kind of going over my approach to these projects and stuff like that. Um, so I'll see you guys next week for my Q&A video. I'm very excited for that too. And yeah, tidy on.